Hi, everyone, and welcome back to another episode in this little mini series called the Fundamental Trig Identities. So, this is episode 5 in this series. I highly recommend watching them in order and starting at the beginning and learning really what are the trig identities. So, down in the left hand corner of the screen, I have the identities right here on a note card. You should have all of those identities memorized. When you have them memorized, they just start to pop out of the screen or your page a little bit more. And everything becomes a little bit easier. So if you haven't taken the time to memorize them yet, I would make note cards and I would memorize these. Okay, so in this question here, we are going to simplify. And simplifying and factoring, those are really important techniques to have down before you try to start verifying. And that's where we're going to move to next is verifying, and then we're going to work on proofs after that. Okay, so we are going to simplify this right here. And what I notice is that I have two fractions being added together. I know that if I have two fractions that are being added together, I need to get a common denominator. Now, the easiest way, not always the best way, but the easiest way to get a common denominator is to take your opposite denominators and multiply them to that opposite piece of the fraction. So I'm going to take this 1 minus cosine and I'm going to multiply it over here. And I'm going to take the 1 plus cosine and I'm going to multiply it over here. And then what happens is I should get the same denominator. Let's do a little side journey here. And let's talk about what if this was just numbers. Let's say we had 2/3 and we were adding that to 4/5. How would you figure out what the total was? Well, you have to get a common denominator, right? So you're going to try to figure out how can I get the denominators the same? Well, I'm going to multiply by 5/5 and 3/3. Why am I allowed to multiply by 5/5? And why am I allowed to multiply by something different there than I did over here? Well, 5 divided by 5 is just 1. And 1 times anything is that thing. So this is 1 times 2/3. It's still just going to be 2/3. When you multiply straight across. So we're going to multiply like that. And so we're going to end up with 10/15. And right here, 4 times 3, we're going to get 12/15. So now I've got 10/15 with, if I reduced that, if I was like, hey, I want to reduce that, I would get 2/3. So 2/3 and 10/15, they're equivalent. That's why I'm allowed to do this. And then I'm going to add it to 12/15. In the end, I'm going to have a total number of 15ths. So 15th is going to be my new denominator. So 10 plus 12 is 22. And then you're going to have 15ths. One thing I want you to remember when you were adding fractions back in the day, long, long ago, after you get that common denominator, that is your new denominator. You're not doing 15 plus 15. 15 is the new denominator. That's telling you the size of pieces they are. And that's going to be the same thing when you start finding common denominators with things that have x's in them or cosines in them and things like that. Okay, so that was our side journey. Side journey concluded. Let's go ahead and delete that side journey. All right. So I want to get a common denominator here. Now, just like we did with regular numbers, we're going to take this denominator and we're going to multiply it to this fraction. So that's going to look like this. 1 plus cosine of x over 1 plus cosine of x. Remember, you're multiplying that 1 plus cosine of x kind of as a team. So to show that they're a team, you just put little parentheses around them, and then that 1 minus cosine of x is also a team. So I've got this denominator here of 1 plus cosine of x times 1 minus cosine of x. I'm going to multiply this fraction by that denominator, so we have a common denominator. So it's going to look like 1 minus cosine of x over 1 minus cosine of x. Remember, the 1 minus cosine of x and the 1 plus cosine of x, they're tied together. they're a team. You can't break them up. Okay, so now, just like we were doing with numbers, we are going to actually multiply these out and we're going to figure out what our answers are. So in my numerator right here, I have 1 plus cosine of x times 1. So you could go through the process 1 times 1 is 1, cosine of x times 1 is cosine of x, or you just know 1 times anything is itself. So this side, I'm going to have 1 plus cosine of x. My denominator, I'm going to do 1 plus cosine of x times 1 minus cosine of x. I hope that you guys are at the point right now that you recognize that that's a difference of squares. If you don't recognize that that's a difference of squares yet, you're going to have to go through the whole process of FOILing it out, multiplying it through. So you're going to have to say 1 times 1, and you're going to get 1. And then 1 times negative cosine, and you're going to get negative cosine of x. And then you jump to your next term, and you're going to say cosine times 1, which is positive cosine of x, and cosine times negative cosine, which is negative cosine squared of x. And then hopefully what you see is that these middle terms cancel out like that, leaving you with 1 minus cosine squared of x. Now, if you recognize that it's a difference of squares, you do not need to show this work. If you recognize right off the bat that this is a difference of squares, that when you multiply it all the way through, you're going to have the first number squared, the second thing squared with a minus sign in between, don't show that middle step. Okay, so we've simplified that fraction. Now we need to simplify this fraction. So we're going to take our 1 minus cosine of x and we're going to multiply it by 1. Go back to the red here. We're going to put plus, and that's going to be 1 minus cosine of x, because 1 times anything is that anything. And we already did the work for this denominator. It's the same exact thing as this. So it's going to be 1 minus cosine squared of x. And it better be the same thing, because we just went through all of that work to get a common denominator. And so if it's not the same thing, you don't have a common denominator, what in the heck did you just do? Okay, so now our next step, just like it was with the numbers, are to add our fractions. Remember, the whole purpose of getting a common denominator was so that now my new denominator is this 1 minus cosine squared of x. It's not 1 minus cosine squared of x plus 1 minus cosine squared of x. You're not doubling it, just like you didn't with the 15s. So it's just 1 minus cosine squared of x. And then you've got 1 plus cosine of x plus 1 minus cosine of x. So you're just taking this and you're adding it to that right there. Okay. Now we need to go through our simplification. Remember, you can only cancel things out if they're in both the numerator and the denominator. You can only cancel things out if they're both in the numerator and in the denominator. If it's not a factor, I don't know if I used that word when I was just talking. It has to be a factor. If they're terms, you can't cancel them out. This is a term. You cannot cancel it. This is a term. You cannot cancel it. Term, with the denominator, I mean. You can cancel it within the numerator, but not in the denominator. Not sure if any of those sentences made sense, but hopefully they did. So we're going to go through our numerator and we're going to combine any like terms that we have. I notice I have a 1 and I have a 1. If I add 1 and 1, I get 2. I notice that I have a positive cosine and a negative cosine. Well, positive cosine minus cosine is 0. Those do cancel out. So, I mean, you can cancel them in the numerator. You can't just cross them off with something in the denominator. Now, the other thing that I notice is this is a Pythagorean identity. And if you have those identities memorized, they just start popping out of the screen at you. It's like smacking you in the face. Oh my God, I see a 1 minus cosine squared of x. That's sine squared of x. So right here, I don't know if you can see where I'm pointing, but I'm pointing at the bottom left part of the screen. Sine squared of x is the same thing as 1 minus cosine squared of x. So I can replace that entire denominator with a sine squared of x. So when we're simplifying now, this is when our Pythagorean identities and our reciprocal identities and our quotient identities are coming into play. You're done when you can't simplify any further. So right now, this is the same exact thing, and you don't have to write this step, but it's the same thing as 2 over 1 times 1 over sine squared of x. If you were to multiply these straight across, which is how you multiply fractions, 2 times 1 is 2. 1 times sine squared is sine squared. I like to write it like this because I think that now it makes it a lot easier to see that 1 over sine squared of x is going to follow this right here. 1 over sine is cosecant, so 1 over sine squared has to be cosecant squared. So the 2 follows us, and we get 2 cosecant squared of x. All right, that's as simple as it gets. Doesn't get any more simple than that. That's it. Okay, when you're working through these simplification processes, you have to do any algebra that comes up. So I added my fractions first. I got that common denominator, and then I started to look at my trig identities. I promise you that if you have these trig identities memorized, it does become so much easier. So in the next episode, I'm going to go through our first verification process.